Hello everyone, you are welcome to the Don's Consult. Today I have a question for you on the topic hybridization. Alright, let's see this question. It says, the compound below contains, this is the compound below. Alright, say it contains A, sp3 hybridized carbon atoms only, B, sp2 hybridized carbon atoms only, C, sp3 and sp hybridized carbon atoms, D, sp3 and sp2 hybridized carbon atoms. Now, before you can answer this kind of question, you must understand what is hybridization. Now, what is hybridization? Compounds that form hybridization, okay, let me put it this way. There are, from what you have seen from the options here now, we have what is called sp2 hybridization, we have sp3 hybridization. There's another one that is not included. Okay, it's here, sp hybridization. So we have sp2 and sp3 hybridizations. And what does this mean? It refers to atomic orbital hybridization, where different numbers of s orbital and p orbitals mix to form a new hybrid orbitals. And this will give you a distinct bond angles and distinct geometries. Are you getting it now? Now, for a compound to form sp hybridization has to do with one s orbital and one p orbital combining together. When one s orbital combine with one p orbital, and that will give you sp hybridization. The bond angle is usually 180 degrees, and that gives it a what you call a linear geometry. Example includes carbon monoxide, acetylene. In fact, most carbon atoms with triple bond form sp hybridization. Are we communicating? Now, what of sp2 hybridization? This is when one s orbital and two p orbitals. When one s orbital and two p orbitals combine, that will give you sp2 hybridization, and it will form a bond angle of about 120 degrees Celsius with a trigonal planar geometry. A good example is benzene, ethylene. Another point you must also understand is the compounds or carbon atoms with double bonds. Usually form sp2 hybridization. All right. Now, how about the last one? That's the sp3 hybridization. sp3 is when one s orbital and three p orbitals combine. When one s orbital and three p orbitals combine, it will form sp3 hybridization, and that will form a bond angle, let's say by 110. Some textbooks will say 109.5 degrees. All right, and it will form a tetrahedral geometry. All right, a very good example is methane. Methane will form sp3 hybridization. In fact, all carbon atoms with all single bonds will form sp3 hybridization. Now, with this explanation, look at the compound now. This is benzene, and in fact, this compound is benzene derivative. Is that right? On this benzene is a methyl attachment. This methyl attachment is from the methane family, single bonds, and this is a benzene. And I told you that ones that have double bonds will form sp2. And of course, you can see that this benzene will form sp2 hybridization. Benzene will form sp3 hybridization. Are you getting it now? So with these explanations now, which of the options? sp3 hybridized carbon atoms only? That will be wrong, because the methane is attached to. It's not only methane. If it's only methane, now we'll go for this. sp2 hybridized carbon atoms only. This one is not even there at all. Is that right? Okay, it's there because this is benzene, because of double bond. Yes, benzene. Okay, sp3 and sp hybridization, no. So you can now see that the correct answer will be sp3 and sp2 hybridized carbon atoms, because this is for benzene sp2 and this is for methane sp3. Do you get it now? So the correct answer is D. That is how simple we can make chemistry for you here at the Don's Consult. Partner with us if you haven't. Press that subscription button and you will learn more. Thank you. See you in the next video.